you have any questions during the presentation, please feel free to type them into the comments, and we'll pick them up and we'll go answer them as we go. Hope everybody's having a good day so far. I'm going to give it another 60 seconds and then we'll get stuck into it. What we'll also do is we'll, if anybody misses anything on the presentation, we'll send it's been recorded, so we'll send it out afterwards anyway, around to everybody. So anything you want to review, you can do, just in case you miss anything or you just want to check the information again. All right, I think we should probably get started. So welcome to the Headland and OMAX Waterjet webinar series. This is week 2. In the first week, we discussed the different thicknesses you can potentially cut with your abrasive waterjet system. But today we're going to concentrate on pressures. There's lots of different information put out there by waterjet manufacturers regarding the pressure their pumps can achieve and what pressure is best to use to achieve the best results from your waterjet. So the idea behind what we're going to talk about today, and this will only last 10-15 minutes. We're not going to talk for too long, because trust me, I could probably bore you to tears for hours on this stuff. We'll just keep it short, we'll keep it sweet, and we'll go for about 10-15 minutes and just basically take you through what the different pressures are, what does it mean with the different pressures available, and what results can you expect to see from the different pressures. That should hopefully give you a good insight into all the information that's been put out there, and hopefully give you an idea of what's accurate and what's not accurate. Okay, so let's start. What we'll do is hang on a second, my screen's playing up on me. There we go. So the biggest piece of information put out there by other waterjet manufacturers other than OMAX is that they can give you a pump that will get you up to 90,000 psi. Now, it's a nice big number, sounds fantastic. But what does it actually mean, 90,000 psi? What does it actually result in? So to explain that to you easily, it's best to explain to you how we generate pressure with a waterjet. So to generate high pressures, you have to restrict the flow of water coming through that nozzle. We restrict the flow of water by putting a smaller orifice in the nozzle. Putting that small orifice on takes the pressure up because you're trying to force the same amount of water but through a smaller hole. Now, the problem with restricting the flow of water through the waterjet means that the amount of water coming through that hole has obviously reduced. Now, what determines how fast the waterjet will cut is not pressure. Okay, that's one of the biggest pieces of information I can put across during this presentation, is that it is not pressure that determines how fast you're going to cut. What does determine how fast you're going to cut is something called hydraulic horsepower of the nozzle. Now, to break that down to simplistic terms, it's the amount of water you can move through your nozzle within a given time. It's not the pressure of the water, it's the volume of the water. How much can you put through that nozzle within a given time? Because the more water you can move through the nozzle, the more abrasive you can move through the nozzle, therefore the faster you're going to cut, because it's the abrasive that's doing the work. It's not the water, it's the abrasive. The water is there merely to carry the abrasive through the nozzle, through the material, and erode the material away. So it's a fairly easy process to understand once you understand the dynamics behind it. Okay, so why 90,000 psi? Why 60,000 psi? As you can see in this slide here, the amount of water we can move with a 60,000 psi nozzle is significantly more than you can move with a 90,000 psi nozzle due to the size of the orifice that you put on to achieve the pressures of 90,000 psi. The type of pump we use is what's called a direct drive pump. Now, we're going to go into the different types of pump later on in the series, but you'll get an idea right now of which pumps are more efficient. So the 60,000 psi pump with a 50 horsepower motor on it cuts 51% faster than a 90,000 hydraulic intensifier pump with a 50 horsepower motor on it. So you've got like-for-like horsepower on your motors, but we're going at 51% faster. And that's represented easily in this photo here, where it shows that 4.91 minutes you can produce this geared part. So that part that's shown up there, in 4.9 minutes you can produce that with a 60,000 psi Enduramax. With your 90,000 psi intensifier, it's going to take you 7.5 minutes to produce that same part. As you can see, the amount of abrasive coming through the nozzle is what's critical. But what that actually means is that you use less abrasive per part. Okay, so although you're putting more abrasive in, you will actually be using less abrasive per part. Okay, now, so we did a little test where we kept the abrasive flow rate the same between the 90,000 psi system and the 60,000 psi system, just to see what difference that made. And the difference it made was that we were actually using 33% less abrasive than a 90,000 psi system per part, because we're cutting it that much faster. All right, so when you talk to other manufacturers and they sit there and they say, oh yeah, we use less abrasive. Yeah, well, you use less abrasive per minute, but we use less abrasive per part because we are cutting significantly faster. All right, so higher pressure does not mean faster cutting. What does mean faster cutting is higher hydraulic horsepower at the nozzle, okay? And that is what you achieve with a direct drive pump. Now, to give you more of an idea of how that works and to give you some numbers to play around with, this is a table showing the different types of pumps available. Okay, so as well as the hydraulic intensifier, there's something called a servo-driven reciprocating pump available as well. Now, the servo-driven reciprocating pump is not as powerful as the hydraulic intensifier, so therefore the efficiencies are even further lower than the hydraulic intensifier, and then even further down on the direct drive that Omax offers. So therefore that one cuts even slower. So you can see down here the efficiency numbers. The reason the Enduramax is so much higher is because it is a direct drive. So the power that is going into that motor is getting directly translated to pressure. It's a mechanical drive. It's not a hydraulic system. It's not a servo system. It's a belt-driven system between the motor and the crankcase. So it's a direct drive. Therefore, there's very little energy lost between the motor and the crank to generate the pressure, which is why we can get 92% efficiency. Now, obviously, in the previous slide, I was talking about the hydraulic horsepower. You can see here on the second to bottom row, the hydraulic horsepower ratings. Now, this is just mathematics. The hydraulic horsepower calculation is nothing more than mathematics. We haven't plucked a figure out the air and gone, yeah, that looks great. It is all calculated out. And if you want the chart that shows the calculations, I'm more than willing to send it out to people afterwards. Just let me know, drop me a message, drop me an email. I can send you the chart and you can work it all out for yourselves and see the numbers. But as you can see here, the Enduramax is running at 45.9 hydraulic horsepower at the nozzle, whereas a 90,000 intensifier is only running at 32.3. Again, that is down to the size of the orifice that you have to put on to generate that pressure. Even the servo pumps, which claim to run at 66,000 psi, are only running at best 29.2. But at actual operating pressure, because you can't actually operate the systems at the pressure they can operate them at, you're only running at 23.4 hydraulic horsepower. As you can see as well, if you step up to the water flow numbers, again, to achieve that 90,000 psi, you can only put through 2.3 litres a minute of water. Whereas with a 50 horsepower direct drive, you can actually put through nearly 5 litres of water a minute. So it's over double the amount of water per minute for the same amount of power input. And it's that kind of efficiency that gains you the much, much faster cutting rates. As you can see, we can put on a much larger orifice, which is what determines your flow rate of water. and that is what determines how fast you'll cut. Now, within the Omax range of pumps, we have two different types. We have the Enduramax and we have the Maxium. The Enduramax is the latest and greatest, and the Maxium is the tried and tested system that Omax have been running for the last 20 years. So it's the same with the Maxium. The highest power Maxium pump that we do is a 40 horsepower. As you can see on the 40 horsepower, we're still at a higher hydraulic horsepower rate than any other pump available. We're still more efficient than any other pump available. So again, it's not the pressure that determines how fast you cut. It is the efficiencies and your hydraulic horsepower and your flow rate of water. That is what determines how fast the water jet will cut. All right. So when people are saying to you, oh, we've got a 90,000 PSI system, we can cut faster, it just simply isn't true. It's purely down to the hydraulic horsepower at the nozzle and the amount of water you can move through, because the more water you can move through, the more abrasive you can move through, the more abrasive, the faster you cut. And it really is that simple. So if anybody wants to know how fast this will cut on their parts, please feel free to send me a DXF file through, or even a drawing, anything like that. I'm more than happy to do a time study. We can play around with different pump sizes, different abrasive flow rates. You know, we can make it work to your situation, make it work to your application. So anything like that comes up, please let me know. More than happy to do that for you. I don't think we've had any questions yet, so I'll just double check, make sure. Yep, no questions so far. I'll go back up the slides. Leave you with that one. Okay, so just touch on something here. It says about with 6,000 PSI, you can have better accuracy. Now, what that basically boils down to is less taper. Because you're moving more abrasive through your part, you can have less taper, okay, which is quite critical on a gear like this. It's quite critical, as you can see here. There's more taper on this one than there is on the top one. Therefore, it's more accurate because you don't have so much taper. Okay, so like I said, any questions you want to put to me, please feel free to type them in, and I'll do my best to get to them. If you want to send me an email, it's mattheww@headland.com.au, or please feel free to give me a call. My telephone number's on the website, and we'll look forward to seeing you all next week. We are recording this, so this will get sent out to everybody. So if you missed anything, please feel free to look through it again, and I'll do my best to answer any questions that come my way. All right, thank you very much, guys, and I'll speak to you all soon. Thanks.